Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
All right, welcome back to another episode of Space on Earth. I'm Lacey.
And I'm Havilah.
And today we're going to be talking about spectroscopy. All right, Havilah, let's start with the basics. What exactly is spectroscopy?
Well, spectroscopy is the study of light, breaking light into its compound wavelengths, which is similar to rainbow through a prism. Every element interacts with light differently, which creates unique fingerprints. This allows scientists to identify materials remotely.
Why does every element have its own fingerprint?
Electrons occupy specific energy levels, and they also absorb and emit specific wavelengths. This creates unique spectral lines, which is why hydrogen looks different from helium, oxygen looks different from carbon.
So astronomers can tell what something is made of just by looking at its light?
Yes, stars, nebula, galaxies, planetary atmospheres, even extremely distant objects. Space telescopes like the Hubble and James Webb Space Telescope use spectroscopy. When did scientists first realize light could tell us what things are made of?
All right, so Isaac Newton split sunlight with a prism, which in turn split the light and you could see the individual colors. In the 1800s, scientists discovered the spectral lines. Joseph von Fraunhofer mapped dark lines in the sunlight, and then scientists later connected lines to specific elements, which caused the birth of modern spectroscopy.
Why was that discovery so revolutionary?
So before stars were mysterious points of light, and then spectroscopy, stars became actual physical objects that scientists could study. It was the first time humans could analyze distant objects without visiting them. Havilah, how do astronomers use spectroscopy today?
They use spectroscopy to determine composition, study cellular evolution, measure temperature, measure density, and even measure motion.
So how do we know what the sun is made of?
Well, through spectral analysis, we identify the characteristics of the sun through spectral lines. Through that, we have learned that the sun is mostly made of hydrogen and helium.
Tell us if the star is moving?
Yes. Through spectroscopy, we can tell whether a star is moving towards us or away from us. Scientists look at the star's spectral lines and compare them to where these lines should normally appear. If the lines are shifted towards the red end of the spectrum, called redshift, the star is moving away from Earth. If the lines are shifted towards the blue end of the spectrum, called blue shift, the star is moving towards Earth. This happened because of the Doppler effect, the same phenomena, coincidentally, that causes a passing ambulance siren to sound different as it approaches and then moves away. By measuring how much the spectral lines shift, astronomers can calculate the star's speed. This technique is crucial for studying stars, detecting exoplanets, and understanding how galaxies move throughout the universe.
So, Havilah, is that how astronomers discovered that the universe is expanding?
Yep, exactly. In the 1920s, astronomer Edwin Hubble observed that most galaxies showed redshift. The farther away a galaxy was, the more its light was shifted towards red wavelengths. This galaxies are moving away from one another. That discovery became some of the first evidence that the universe itself is expanding. It remains one of the most important discoveries in modern astronomy.
So, one of the coolest uses of spectroscopy is finding planets around other stars. How exactly does that work?
Well, that works through radial velocity method. Planet gravities pull on a star. The star wobbles slightly, and spectroscopy detects that tiny shift in spectral lines. That's why thousands of exoplanets have been discovered.
Tell us what's in a planet's atmosphere? Can spectroscopy tell us what's in an exoplanet's atmosphere?
Yes, and it's one of the most exciting uses of spectroscopy today. When an exoplanet passes in front of its star, a tiny amount of the star's light travels through the planet's atmosphere before reaching our telescopes. Different gases absorb different colors, or wavelengths, of light. By looking at which colors are missing from the light, scientists can figure out which gases are present in the atmosphere. It's similar to identifying a fingerprint. Every gas level has its own unique pattern in the light. Using this method, astronomers have detected gases such as water vapor, carbon dioxide, methane, sodium.
That is quite fascinating, actually. All right, what spacecraft uses spectroscopy?
A lot of different spacecraft use it, including the James Webb Space Telescope, the Hubble Space Telescope, MAVEN, Mars Reconnaissance Orbiter, Preference Rover, and
How has the James Webb Space Telescope used spectroscopy?
it's used spectroscopy to study exoplanet atmospheres, analyze distant galaxies, detect molecules in space, and observe early universe chemistry. What makes spectroscopy culturally important?
Spectroscopy is culturally important because it changed humanity's understanding of the universe, and it connected humanity to the cosmos.
Oh, there's a famous quote that we're made of star stuff. How does spectroscopy relate to that?
Ooh. So that famous quote was from Carl Sagan. Sagan helped bring astronomy to the public through books and TV. Spectroscopy helps scientists determine what stars are made of. By analyzing starlight, astronomers discovered that stars contain elements like hydrogen, helium, carbon, oxygen, nitrogen, and iron. Later, scientists realized those same elements, planets, and living things, including humans. Many of the heavier elements in our bodies were forged inside stars and distributed throughout space when those stars died. In a very real sense, the atoms that make us were once part of ancient stars.
Wow. Why do you think people find this field so fascinating?
So, it's invisible information hidden in light. It feels almost magical, and it shows the power of human curiosity. It shows how in tune we want to be with our universe, and we find the unknown to be. So, will spectroscopy play in the future of astronomy?
Spectroscopy will play a role in the search for life, better exoplanet studies, mapping galaxy evolution, understanding planetary systems, and even future observations.
Could spectroscopy someday help us discover life beyond Earth?
Potentially, yes. It could help search for biosignatures, for oxygen, methane, and is one of the most promising methods.
That is quite amazing. So, today we talked about all the amazing uses of spectroscopy, how we as humans connect to space, how we get to discover more about our unknown universe.
Thank you for joining our episode in which we discovered what spectroscopy is, some of its uses, possible future things we can be using it for, and what makes spectroscopy culturally important.
Thank you for joining us on episode 14, season 2. Visit STEMartslab.com to learn more about some of our other projects. I'm Lacey.
And I'm Havilah.
And we will see you next time on Space on Earth.